Fantastic. So we have seen one example with respect to the z-test, and we got the clear-cut understanding regarding the z-test. But if you observe and if you followed my videos, you would have seen two different way of calculating z-score or z-statistic. Why so? Why is that? What is the difference? This kind of questions might come in your brain. Even if you search in internet, you will find two different formulas for z-score. Why is so? Why is that? Why so? So this question is going to be answered in the following slide. So z-score versus z-score for sample data versus z-score for sampling distribution. To understand the difference between those two formulas, first you should understand what is sample distribution and what is sampling distribution. So we are going to address this issue first, then we will get into the z-score for sample data, z-score for sample, and z-score for sampling distribution. So z-score represents a statistical technique of measuring the deviation data from the mean. So it's also used with z-test, which is a hypothesis testing statistical technique. One sample z-test or two samples z-test. We have done a two sample z-test or two-tailed. So as a data scientist, it is utmost importance to be well versed with the z-score formula and its various applications. Having a great clarity on the concept of z-score and or z-statistics will help you use the correct formula for calculation in the appropriate cases. So now let's begin. So z-score formula differs when considering the sample data or when considering the sampling distribution. So with an end goal of whether finding the deviation from the mean or performing hypothesis testing respectively. So first we will see z-score for sample data. So in case of z-score for sample data, the objective is to find number of standard deviations and observation is away from the sample mean. So let's begin with this example. Here, this is the sample which has been picked from Bengaluru city's population. Okay. So using random sampling. So we have a Bengaluru population. We have a Bengaluru population. Again, hypothetical. Don't take the values exactly. So let's take Bengaluru population, which is around 1000. So from that, we have taken a sample of maybe 80. That's what the sample we have taken. So what you see is a sample pupil from a Bengaluru city. Bengaluru city. Okay, done. Now, so now what I am gonna do is, so after taking the sample, I have measured the height of each and every element in our sample. After measuring each and every element's height of this old lady, height of this young kids, height of this mota boss, this guy, and height of this girl, height of this angry girl. So we have measured height of each guy, each entity or each element in our sample. Then we have made a histogram or frequency distribution plot, and that's what we call as a sampling, that's what we call as a distribution. So distribution of heights of sample from the Bengaluru, and this is what we got. close to normal distribution. Okay, so first let's code this concept also, then we will see how to calculate the z statistic for this case. So let me check this. Let me call up what I import numpy as np and import pandas as pd. Done. Now it's time to load the data set. So I'm going to load the data set, which is sample data from the Bengaluru city. Okay, so data is equal to pd dot read csv and it's heights dot csv. And if you just want to see what is that data, let me just check it out. This is what is the data, and it's 1000 rows. It's a huge data, and this is height of each element in a sample. That sample has been taken from the Bengaluru population. Okay, so that's what is our data. Now it's pretty straightforward. If you create a sampling distribution of this, if you create a distribution of these heights, or frequency distribution of heights of these elements from the sample, so that's what is called a sample distribution. Just a distribution, just a distribution of this data. That's it. Let's do that. So what I'm gonna do is, let me import. Okay, I need to import matplotlib. Import matplotlib dot pyplot as plt. So now what I'm gonna do is plt.hist and so heights, that's what my data set, and I'm gonna go for bins of 30. Are they enough? Yeah, that's enough. Then plt.x label, which is height, obviously in centimeter. plt.y label, and this is frequency. I told you the frequency distribution, frequency of height under in the sample data, and title. So distribution of heights. Okay, that's it. It's time to show the plot. And here it is. This, what we call it as a distribution of heights plot. Okay, simple, pretty straightforward. You have taken a sample from the population, and then you have plotted the height frequency distribution. That's it. Okay, so now let's get into the core of the slide. So which is z-score calculation for this sample. How do you calculate z-score for this? When considering a sample of data, just a sample of data, z-score is used to measure the number of standard deviations by which the data points in the sample differ from the mean. Alternatively, when define the population, z-score can be used to measure the number of standard deviations by which the data points differ from the population mean. So this is also called a standard score or z-score or z-statistics. So how do we calculate that? Using z is equals to x minus x bar divided by sigma. So here, where x is the observation in the sample, any observation means any entity, any element of the sample's height. That's it. Okay, that is x. and x bar is the mean of the observations in the sample. So mean of the whole sample, this whole sample. So this if you take this, guys, if let's take average height is 170 centimeters and this girl's height is 140 centimeters. So now 140 centimeters minus mean height of this sample group is 170 centimeters. So 140 minus 170 divided by, if it is a standard deviation between each element is 10, then 140 minus 170 divided by 10. So sigma is the standard deviation of the observations in the sample. Okay. So this is how we calculate a z-score for a population, z-score for a sample. It could be a population or it could be a sample. If you want to calculate directly on the population also, you have to use the same technique. Same technique. Or you have a variable in your data set, and if you want to calculate a z-score for the data set, again, you have to follow the same technique. Obviously, you have to follow the same technique. Okay, this is what is z-score for sample data. This is a one way of doing. Next, let's go for the second way. Second way that we have here is z-score for sampling distributions. So in case of sampling distribution, the goal is to perform z-test and find the value of z-score or z-statistics for hypothesis testing and rejecting the null hypothesis or otherwise. So that is the main goal. Whereas z-score that we use for z-score that we use it in sample data, the objective is to find the number of standard deviations an observation is away from. Simply there, z-score normal in this case, the first case, it can be used to find the outliers or just to understand how far, just to understand the overall standard deviation, how far a certain this guy, how far the height of this guy or this girl has been, how far it is from the mean of the whole data. So that's the main objective of this formula or this case. Whereas in second case, whereas in z-score for sampling distribution, the goal is completely different. There we perform z-test. So that is the reason in my previous videos I have mentioned the z-score of this formula and I have mentioned completely different formula. So that is used for the hypothesis testing, a statistical significance test. So that is the reason I'm explaining both in a single slide. So z-score for sampling distribution, the goal of this is to perform z-test and find the value of z-score or z-statistics for hypothesis testing and rejecting the null hypothesis or otherwise. Okay, now let's continue with this example here. So now, in spite of what we'll do, before we have taken only one sample from the whole population. So this time, what we are going to do is, let's take the Bengaluru citizens. That's the whole population. That is our whole population. Bengaluru pupil is our whole population. From there, I'm going to take three samples. Okay, different samples. So out of that, this is sample 1. This is sample 2. And this is sample 3. Like that, you can take n number of samples, 1000 number of samples. Okay, I have taken 3 samples. You can see that from here. So this is basically, I have taken 3 samples from the population of Bengaluru, Okay, so now what I will do is, I will take n number of samples, maybe 1000 samples, and for each sample will consist of a sample size is 4, and I will calculate the mean height, or for each sample, mean height of sample 1, mean height of sample 2, mean height of sample 3, and then these mean heights of each sample, if I distribute, that's what is called sampling distribution of the mean. So Sampling distribution is nothing but from the population taking more number of samples and calculating the mean of the respective variable. Here in this case it's a height, some other cases it could be weight, in some other cases it's a diameter of the balls, some other cases it's some other thing, but here it is height. So that is the reason I have to calculate the mean height for each sample, and then I have to plot the means of each sample on your histogram. That's what is sampling distribution. Whereas in normal distribution, here you are directly plotting heights. Here we are plotting mean heights of each sample. That's the main difference. So that's the reason the things will change. Okay, now let's write some code and create this. How to create that huge number of samples. For that we can use bootstrapping. Let's do that. So now the first one, what you see is a Z score for sample data. Okay, this is Z score for sample data. So let me put everything at one place so it would be makes more sense. Yeah. So next we will work on Z score for sampling distributions. So for that we are going to plot sampling distribution. Let's plot sampling distribution. One is sample data distribution, other one is sampling distribution. One is normal distribution, this is just a normal distribution, sorry, just a distribution, and other one is sampling distribution. Okay, so let's do that sampling distribution. Now to do sampling distribution I require so what I have to decide is sample size. What could be the sample size? I'm gonna use same data. So heights, that's this is the data I'm gonna use. Okay, so what I'm gonna do now, I have to write the sample size. So I'll go with the sample size of 10 so that I can show you sample size of 10. Then how many times I want to take bootstraps. Okay, bootstrap sampling, that's what I'm gonna do. Bootstrap sampling is nothing but, here let's imagine this is your population. Then let's imagine sample size is just 4. Then first I will pick this woman, then she will be removed from here. Then how many remaining entities will be left? Now I can take one more element from remaining guys. If I take this girl, then only these people will be left. Then I will take one more girl from remaining batch. So the first level of random sampling will be done without a replacement. Then after checking the sample 1, we will calculate the mean height of the sample 1. Then we will replace the sample 1 into the population. Then again your population will become bigger as usual, normal. Then you take one more sample, one more random sample. Then you will calculate the mean height of that, mean height of the sample 2. Then you replace it, whole sample. Then you take one more sample. Then you replace it again, calculate the mean height and replace it, and like that you will repeat it 1000 times if you want 1000 bootstraps. So if you want 1000 bootstrap, you have to do it 1000, you have to take 1000 samples. If you want 10,000 samples, then you have to do 10,000 bootstraps. 10,000 you have to repeat. Okay, that's what is bootstrapping. So now here number of bootstraps or number of samples that I require is 1000. That's it, rest all done. So now I have to do a small loop here. So that's what, so let me say bootstraps mm, let me say bootstrap means, because obviously this is sampling distribution. For every sample we have to calculate the mean. That's the reason I'm putting mean. So for uh, I in range of number of bootstraps, it is 1000 divided by bootstrap sample. Here that's what first we'll take bootstrap sample. And bootstrap sample how to make from random module. From there I'll take the choice method, and inside the choice method you can just first you have to give the data set data or array basically. Then after that, whether you want to do replace with replacement or without a replacement or remaining things, you can basically look here. Okay, so I'll go with replacement here. Obviously that's how bootstrapping works. You have to replace the sample and make the population as usual, then you take the random sampling from that. That's how it works. So that's what I'm trying to say. So heights, that's our data frame. Directly I'll give heights. So heights has been given. Now that's done. So this is what the bootstrap sample for us. So now let's continue. So bootstrap mean, so now the with this step the sample will be picked. So once the sample is picked, now we have to calculate the bootstrap mean. So to do that, you have to just use mean function or mean function from that np numpy, then simply give that bootstrap sample. So mean is ready. Now it's time to append all these means into bootstrap means. So bootstrap means dot append and bootstrap mean. That's it. All set. All done. So let's try to see print. What I want to see is bootstrap sample. I just want to see bootstrap sample first, and then I'll see remaining things. Bootstrap mean and bootstrap means, and that's it. You see, I'll remove this. Obviously bootstrap means you will have a complete, we want 1000, so you will have 1000 bootstrap means because that many samples were created. Okay, so let me execute this again. So as I have told you, each sample size will be 20, because sorry 10, no 10, that's what I have decided. So here also you got the 10, 1 2 3 4 5 6 7 8 9 10. So and this is the bootstrap mean of this sample. So let's execute one more time this code. This time the sample will change. So this time it's 167.2. Okay, so it will keep on because it's going to take a huge number of samples every time. It's going to bring a new sample. So that's what let me give the random state 1, and here is the change. And let me give the 42 seed 168. Okay, because it has 1000 samples, because we want to create 1000 samples. The number of samples are 1000. So each sample size is 10, and then this is the mean of each sample. Now let's see the means of all samples. So print, it's sample means. Okay, this is bootstrap means, sorry, bootstrap means, and this is what, okay, it's not making much sense. Let's say df is equal to pd and data frame, and it's bootstrap means, and let me say df, and this makes more sense. You see that you got 8000 rows, 8000 rows, and these are all means. These are all bootstrap means. Clear? So this what we're going to plot now. Okay. So now let's plot this. I hope things got clear. So now let's plot. So what we're gonna do here is, just a minute. Yeah. As usual, let's take PLT hist and bootstrap menu means. So there we gave heights directly, but here we are giving the means of each sample. That's the difference. So and bins I'll go for 30. Is it okay for you? And then remaining things I'll just copy from the above. So height, no, this is not height in centimeter. This is sampling mean. Okay, sample mean height in centimeter frequency, and this is sampling distribution of mean heights of samples. Execute it, and here is the magic. Oh, fantastic. Pure normal distribution. Closer. So what you see is a mean. This is mean. And this, what you see is height in centimeters. And here what you see is a mean height. That is the difference. And this is normal distribution. This is sampling distribution. That's the reason the z-score for here is different than z-score or z-statistic for here is different. Here the z-score will be calculated just to understand if any point, for example 150 or 160 or 162, 163, how far from the mean of this normal distribution curve. That's the main agenda of calculating the z-score, or to find out the outliers. That's the main agenda. But when it comes to sampling distribution, the main agenda is not that. The main agenda is to do z-test. The main agenda is used to, the main agenda in sampling distribution is to do the hypothesis testing. The main agenda of sampling distribution, the z-statistic in sampling distribution, is to find out the relationship between two, statistically to tell the relationship between two variables, or between a feature and a target variable, whether it is statistically significant or not. To say that you require a z-score in a sampling distribution. So that is the reason the z-score in sampling distribution is different, and the z-score in just a distribution is different. Okay, I hope you got the point. Let's get back to the work. So this is the difference between a sample normal data and then sampling distribution. Okay, now let's see the z-statistic for sampling distribution. The formula is equals to z is equals to x bar minus mu divided by SE. So here in this case x bar is sample mean, and mu is population mean, or mean of the observations in the population. In this case, mean of the whole Bengaluru, mean height of the Bengaluru population. And x bar is, we have a lot of samples, out of that any samples mean. Okay, and divided by standard error. So the population mean is denoted by the mu, and the sample mean is denoted by x bar, and SE is standard error of the sample mean. So the standard error of the sample mean can be calculated as sigma divided by square root of n, where the sigma is the standard deviation and n is the sample size. That's it. So this is how we calculate, we use different formulas for different conditions, but the aim remains, the aim is specific to the purpose. In this case, it's just to understand the how far the respective data point or respective observation from the mean. But here in this case, we want to do hypothesis testing. We want to do significance test. That's the reason. So as a data scientist, both are useful. So this Z-score will be useful in outlier detection, which is part of either data cleaning or exploratory data analysis. Whereas this Z-score formula will be useful in feature engineering, where you can identify, you can find out the statistical significance of the relationship between the two variables. So basically, the second formula can be used to engineer the features. So that's the reason this will be used in feature engineering. And the first one is EDA. And that is the difference for you.